Welcome back to the deep dive. I want you to just look at the device you're using right now. Maybe it's a phone in your hand, maybe a laptop. You press a button, a light comes on, and suddenly you have access to, well, the entire world. It feels like magic, right?
It really does.
But today we're going to talk about the invisible hand that makes all that magic happen, the thing you stare at all day but probably never actually see. I'm talking about the operating system.
It is the unsung hero of the digital age.
Right.
Without it, that expensive piece of glass and silicon in your hand is just a paperweight.
A very expensive paperweight, exactly. And look, we all know the cast of characters here. You've got Windows, you've got macOS, you've got Linux.
The Titans.
They're the Titans. They've been running the show for decades.
Blech.
But, and here's the twist. We're recording this in February 2026. The tech landscape is, it's shifting under our feet.
It really is.
We aren't just clicking buttons anymore. We have autonomous AI agents doing work for us while we sleep. And that brings up a massive, uncomfortable question. Are the operating systems we've used for, 40 years? Are they actually becoming obsolete?
That is the core question. It's not just about, is there a new update for Windows? It's about whether the fundamental architecture of how we compute is broken for this new era.
Right.
And to explore that, we have a fascinating source today. It's an article published just yesterday by Dr. Edwin Hernandez. He's often called Dr. E on LinkedIn.
Okay.
It's titled Modern Operating Systems for AI Agents.
And this isn't just a history lesson or, a complaint session. Dr. E is actually proposing a solution, specific innovation called MEVR-OS.
Yeah, and he references a U.S. patent he holds, number 123463999.
So our mission today is to track this evolution. We're going to go from the desktop systems we know and, let's be honest, love, to this wild concept of a distributed operating system.
One designed for a world of decentralized AI.
Exactly.
And I want to flag something right at the start. The distinction between desktop and distributed isn't just jargon. It changes the physics of how computing happens. It changes who owns the computer and where the brain actually lives.
Okay, so let's unpack this. Before we get to the sci-fi sounding future stuff, which we need to understand the incumbents, the big three.
The baseline.
Right. And Dr. E breaks them down really well in the article and honestly made me realize how little I knew about the thing I use every single day.
It's surprising, right? And he starts with the absolute dominant force, Microsoft Windows.
The giant. As of 2023, Dr. E notes they still held over 70% of the market share. That is wild longevity.
It's like the Toyota Camry of operating systems. It's just everywhere.
It is.
And its dominance is rooted in how they built it. Windows, which evolved from the ancient days of MS-DOS, uses what's called a hybrid kernel.
Okay, stop right there. Hybrid kernel. That sounds like a type of corn. We need to break this down for the listener because this kernel concept is crucial to the whole argument.
It is, absolutely. Okay, so think of an operating system's kernel like a restaurant kitchen.
Okay, restaurant kitchen.
The kernel is the staff that actually makes the food. And the food is, the processing power and memory.
I'm with you. Kitchen staff.
So in a monolithic kernel, which is what Linux uses, it's like having a head chef who does absolutely everything.
Yeah.
Shopping, cooking, plating, washing dishes, all in one station.
Sounds efficient.
Hence,
No wasted time handing plates back and forth.
incredibly efficient. It's fast. But if the head chef cuts their finger, the whole kitchen shuts down. The whole system crashes. That's the risk of monolithic kernel.
Okay, so high speed, high risk.
Then you have the microkernel. This is like having separate stations for everything. One guy chops onions. He hands it to the guy who sautés.
I see.
He hands it to the guy who plates. If the onion guy, passes out, the rest of the kitchen keeps running. It's super stable.
But I'm guessing all that handing back and forth, that slows things down.
Exactly. That's latency. So Windows decided to compromise. They built a hybrid kernel. The NT kernel, which has been the heart of Windows since the 90s, tries to keep the speed of the single chef, but, puts up some safety barriers.
So it's the best of both worlds. Or it tries to be.
It tries to be, in theory. But Dr. E points out that this adds complexity, and specifically Windows has a massive focus on backward compatibility.
Right, so you can run apps from 20 years ago on Windows 11.
You can. Which is great for businesses, but I guess that means you're carrying around a lot of old luggage.
A lot of bloat.
Exactly. It adds bloat. Windows is designed to be everything to everyone. It has the NTFS file system. It's very heavy on the graphical user interface. It was built for the masses. But It's heavy.
Okay, so that's the generalist. Then we have the backbone of the internet, Linux. You mentioned the head chef analogy, the monolithic kernel.
Right. If Windows is the office building, Linux is the steel and concrete foundation under the city.
I like that.
Dr. E highlights that while you might not use Linux on your laptop, it powers over 90% of cloud servers and supercomputers.
90%.
Oh.
That's just staggering.
It is, and it's because of that monolithic design. In Linux, all the core services run in kernel space, so it's incredibly fast and efficient.
Which servers love.
They do. It's open source, it's modular, and it prioritizes stability above all else.
Dr. E mentioned something about the file system here, too, X.4.
Yeah, X.4. It's just incredibly robust. It doesn't get corrupted easily. And Linux handles multitasking with something called the completely fair scheduler.
I love that name. The completely fair schedule.
I know, right?
It sounds like a kindergarten teacher making sure everyone gets a turn on the slide.
That's actually a perfect analogy. When you have a server running thousands of requests, you can't have one greedy program hogging the CPU.
Right?
The scheduler ensures every process gets fair access, so the whole system doesn't choke.
Then we have the third player, the one that creatives love, macOS.
Yeah, macOS is interesting because it's also a hybrid like Windows, but it's built differently. It uses a kernel called XNU.
XNU. Let me guess, another acronym.
It stands for X is not Unix, which is a classic nerdy developer joke.
Of course it is.
But structurally, it combines the Mach microkernel, which handles messaging, with BSD Unix, which gives it that rock-solid stability.
And Dr. E emphasizes how tightly integrated this is with the hardware, especially with the Apple Silicon M series chips.
Exactly. Apple controls the whole widget. The hardware and software are designed together.
Which is why that Aqua interface is so buttery smooth.
But, and this is the key point the article makes, all three of these, Windows, Linux, macOS, they all share a common limitation.
Oh, what's that?
They are centralized. They are designed for a user sitting at a single machine.
Right.
Even a server is just a machine managing requests. They have a centralized point of control. And Dr. E argues this architecture is becoming a bottleneck in an era where we have more devices than we have hands.
Which brings us to the pivot point of today's deep dive, the shift to distributed operating systems. Now, when I hear distributed, I think of like cloud storage. But an entire OS, how does that work?
Imagine if you took, say, 5 different computers, your phone, your laptop, your TV, maybe even your car, connected them, and installed software that made them act like one single supercomputer.
Okay.
To you, the user, it just looks like one system. You don't know which specific machine is running your program. The OS handles all that distribution for you.
So it's like a hive mind for my gadgets.
That's a perfect way to put it. And this isn't entirely new. The article mentions historical attempts like Amoeba from Vrije Universiteit Amsterdam and Plan 9 from Bell Labs.
Plan 9, yeah.
These were early attempts to treat clusters of machines as a single entity.
But if we had these ideas back then, I mean, Plan 9 was decades ago, why aren't we all using distributed OSs now? Why am I still wrestling with Windows 11 updates?
Because it's incredibly hard to pull off. I mean, you have issues with network latency speed matters. If I move my mouse, I can't wait half a second for the cursor to move.
Sure.
Then you have data consistency problems. If I change a file on one node, does the other node see it instantly? And synchronization is, well, a nightmare.
So the tech just wasn't ready. But Dr. E believes we've solved enough of these problems to try again. This brings us to his proposal. M via OS.
Yes, ME via OS. This is detailed in that U.S. patent, 12346399. It's a distributed OS, but it's designed with a very modern twist. It's built for a no-app revolution.
Hang on, no app.
Yeah.
That sounds like we're going backwards. We spent 15 years being trained that there's an app for that.
Right.
Why would we want to get rid of them? I like my apps.
Do you? Or do you like the service they provide? I mean, think about the friction. You buy a new smart light bulb, you have to download a 200 millib app, create an account, verify your email, update the firmware.
Just to turn a light on.
Just to turn a light on. That is app fatigue.
Okay, that's fair. I have a folder on my phone called Junk, just for those one-time apps.
Exactly. Dr. E's argument in the patent is that this app trap creates silos. EMEA proposes that the app should just be a URL.
A URL.
You don't install anything. You scan a QR code or hit a link, and the interface loads instantly via standard web tech, HTML, CSS, JavaScript.
So the app is ephemeral. It exists while I need it, and then it just vanishes when I don't.
Precisely, but the architecture is what's really cool. It separates the controller from the display.
Walk me through that.
Okay, so in the Amevia model, your mobile phone acts as the input controller. It can emulate a keyboard, a game controller, or even a 3D gesture recognizer.
Okay, and where am I looking?
You're looking at a smart TV or some large screen which acts as the display or the rendering device. And in the middle, there is this thing called the Device Connect Platform, or DCP.
The DCP.
It handles all the messaging between your phone and the screen.
I have to play devil's advocate here. We're talking about sending touch signals over a network, over the web, to a TV screen. I get lag just trying to stream a YouTube video sometimes.
Yeah.
Wouldn't this feel incredibly sluggish?
Yeah.
I mean, if I swipe on my phone, I want that screen to move now.
That is the million-dollar question. And usually you'd be right. If this were standard HTTP requests, like loading a web page, it would be terrible. But the patent specifically talks about using WebSockets and WebRTC.
Okay, so how are those different?
Well, WebSockets open a persistent bidirectional pipe between the devices. It's not request-response wait. It's a continuous stream. The latency is measured in milliseconds.
So it's like a dedicated lane on the highway.
Exactly. And here is the technical nugget that I found fascinating in the source. The article describes the data flow. Your phone captures a touch event. It converts that into a JSON message.
JSON is just a text format for data, right?
Yeah.
It looks like code, but it's readable.
Yeah, it's remarkably simple. So your phone sends a little text message saying, for example, AVT touch start X100 Y200.
That's it.
That's it. It beams that text to the screen, and the screen reads it and renders the action.
That seems incredibly lightweight compared to how Windows handles a mouse click, which involves like interrupt requests and kernel drivers and all that.
It is. It strips away all that overhead. And because it's using WebRTC, it handles real-time communication perfectly. The patent even mentions using LSTM models for 3D gesture recognition. So you could wave your phone in the air to control something on the screen, and the system understands the depth and motion.
And it mentions ultra-wideband, UWB for proximity, so the room knows I'm there.
Precisely. It's creating a spatial computing environment using web tech. And Dr. E notes that it can even integrate with legacy systems. It can route messages to a Windows machine if it has to.
So it bridges the gap.
It bridges the gap between the old world and the new.
Okay, so we have this new architecture. Phone is controller, screen is display, everything happening over the web via JSON. But why? Why do we need this shift right now? Is this just for playing games on my TV?
No, and this is where the agentic part of the title comes in. This isn't about gaming. This is about survival in a world of agentic AI.
Agentic AI. This means AI that has agency. It can do things on its own.
Right.
It's not a chatbot you talk to. It's a bot that does work.
Correct. The article gives a prime example that launched just recently in January 2026. OpenClaw.
OpenClaw. I have heard of this. Formerly known as ClaudeBot or MoltBot.
Yes. It's an open source autonomous agent, and it's huge. It got over 100,000 GitHub stars almost immediately.
So what does a day in the life of OpenClaw look like?
Well, it runs locally on your machine. It can integrate with WhatsApp, Slack, Telegram. It sends emails, manages your calendar. It can even write code to improve itself.
Wow.
It has a heartbeat scheduler, meaning it wakes up and does things without you telling it to.
That sounds amazing, but also slightly terrifying. I'm imagining my helpful AI assistant, which knows my calendar, my bank details, my emails, suddenly deciding to go rogue because I clicked the wrong link.
That is a very valid fear. And if you run OpenClaw on a traditional OS like your Windows laptop, you had some major problems. First, security. If you misconfigure this agent, you've basically created a backdoor into your personal computer. An adversary could just commandeer it.
Yikes. So my helpful assistant becomes a spy.
Potentially.
Yeah.
But there's a more practical problem, the single point of failure. Let's say you have OpenClaw running on your laptop. It's supposed to be monitoring your emails 24/7. But then you close the lid of your laptop.
And the laptop goes to sleep.
And the agent dies. It can't work if it lives in a box that you turn off. It's like hiring a security guard who falls asleep every time you leave the room.
So this is where the distributed OS BVO wins.
Exactly. In a distributed system, the agent doesn't live on your laptop. It lives on the network of devices. It lives on the MEDIA OS grid.
So if one node fails, say my phone runs out of battery or I shut my laptop, the agent just keeps running.
Yes, it jumps. If the laptop sleeps, the agent process migrates to the smart TV, or a cloud node, or a desktop in the other room. That's fault tolerance.
Resilience.
The article uses the term resilience. In a world of agents, you need the environment to be resilient. You can't have your executive assistant vanish just because a power cord got pulled.
That makes so much sense. It reminds me of how electricity works. I don't care which power plant generated the electricity, as long as the light stays on. And Dr. E uses this analogy of resource allocation. Instead of the agent being stuck in one house, it lives in the city grid.
Right. If it needs heavy compute power for a moment, maybe to render a video, it shifts that task to a node that can handle it. If it just needs to display a notification, it pushes that to the nearest screen.
It decouples the brain from the box.
It decouples the brain of the computer from the physical box in front of you.
It's fascinating because it feels like we've been heading this way with the cloud, but this brings it down to the personal device level. It's not just Amazon's cloud. It's my personal cloud of devices acting as one.
And that distinction is vital. Platforms like EMEA or DAgent AI, which is also mentioned, are trying to give that power back to the user's ecosystem rather than just renting it from a giant server farm.
So we've gone from the monolithic kernels of Linux, the efficient but fragile head chef, through the hybrid polish of macOS and Windows, and now we're looking at the horizon of distributed OSs like EMEA.
It's a logical evolution. We went from mainframes to desktops to mobile, and now to distributed agent networks. The software beneath the agents has to change to support the agents above it.
It really challenges the idea of what a computer is. I think we're so used to pointing at a box and saying, that's my computer.
We are.
I have my stickers on it. I have my files on the desktop. I'm strangely attached to it.
We all are. It's our personal space.
But in Dr. E's vision, the computer is just the air around us, connected by these JSON signals. If the operating system of the future is purely web-based, and it's distributed across all our devices, phones, TVs, maybe even our refrigerators, does the concept of my computer disappear entirely?
That is the ultimate philosophical question here.
Are we moving toward a world where we don't actually own the computing power anymore? Where we just own the access credentials, the keys to the network that runs our life?
It's a shift from ownership of hardware to ownership of identity. If your agent follows you from room to room, from device to device, then you are the computer. The devices are just windows you look through.
That is both liberating and a little bit haunting.
It is. But if we want AI agents that truly work for us, 247 without being tethered to a battery bar, we might have to let go of the box.
A digital environment for an agentic world. Dr. E certainly seems to think that's where we are headed. This has been a massive deep dive, from kernel architecture to the ethics of ownership. Thanks for listening to this exploration of the future of operating systems.
Yeah, thanks for joining us.
We'll catch you on the next one.